with adding and subtracting, it's usually where students make the most number of mistakes. It's hard, so the most number of steps. And you start confusing stuff from the earlier part of the chapter, right? So what students tend to do, one of the mistakes they tend to do is they want to execute the multiplying rules. They'll see something like this, oh, a 2 over here and a 10 here. They want to do that cross simplifying and stuff like that. It doesn't work for adding. It doesn't work for subtracting. That only works for multiplying, right? And divide. With division questions, we switch it to a multiplication. So, like, when we do that cross simplifying stuff, let's grab it on. Maybe I'll do it on the screen here. You don't need to write this part down. If we have like 4, 6 times 8 and 7, and if you want to cross the 4 and 8 out, technically what we're doing is a division. We're not just writing it down because this divided by 2 or divided by 4. We don't write that down because it gets messy, gets out of the way. We just go like this, go like this, right? We can do that because multiplying and division are the same thing, right? So we can do it on the same number or we do it across, as long as it's connected by a multiplying sign, right? It's all the same thing. But when you start separating by a plus sign, you can't do that. You can still simplify top and bottom like this if you wanted to, because they're separated by a fraction line, which is a division sign, right? But you can't go left and right because you're separated by a plus sign. It's a stop. You can't do that kind of business, right? So all we can do is follow the adding rules, which are exactly what you learned last year, right? The questions get a little bit more complicated than last year because the numbers are bigger and there's more negative signs everywhere and all that kind of stuff, right? All right, so I'm gonna kind of jump around, just like multiplying, right? We want to find positive pairs. If you have tons of negative signs, find the positive pairs of the two negatives, right? Now, talking about the negative signs, if you cancel all your positive signs out and you end up with an extra negative sitting around, my suggestion is to move that negative sign to the numerator, right? Find the negative signs. So let's just go, I'm kind of jumping around it. Always move the negatives to the top, to the numerator. All right? Find the positive pairs. Oops. Find the positive pairs and move it to the top. And one of the other rules is, hey, if you have a mixed number, doesn't matter if you're multiplying, dividing, adding, or subtracting, convert it to an improper fraction first. Then do the math operation, right? Whatever the math operation is. So if you have a mixed fraction like this, turn it into an improper fraction first. So work with improper fractions. All right. Now, the hard part of adding and subtracting is, remember, adding and subtracting is just counting. Julian has 2 apples, Mason has 3 apples, altogether there's 5 apples, right? If you're throwing Malik in the mix and he's got a couple bananas there, we can't say he's got 3 bananas and say 2 plus 3 plus 5. It doesn't, what number does that make? It doesn't make any kind of sense. Malik throws a wrench into this whole thing, right? All right, always. So when we're adding something, let's go off to the side. We have, I'm going to write this down. You don't have to write it down, but I like to say this out loud. This fraction, I have 2/3. That's what the first fraction says. I have 2. Maybe I'll write it. I have 2/3. This one says I have 1/4. And then if you're adding, you're trying to count these two things together. How many do you have altogether? And it's hard to say that when you're counting different things. I'm counting slices cut up in thirds. I'm counting slices cut up in fourths. How many do you have altogether? That's hard to say. Some of you guys might be clever enough to be able to do it. It's easier to do counting if you're counting the same thing, all apples, all bananas. So what we do is we change the denominators so they're exactly the same, so we can just count them, right? So what we do is we find the lowest common denominator. And we did this on the very first lesson of this chapter. It's just finding the lowest common denominator. We go, for this example, is we go, hey, I got a 3 and a 4. What number can 3 and 4 both fit into? Remember doing that? And we, no?
Can I say?
Yes? 12. Remember we grabbed our multiplication chart and we went, here's the number 3. Oops, maybe I'll do this one. Here's the number 3. Here's the number 4. We look across, find the multiple that's the same. There's 12, right? There's also other ones, right? There's 24, there's 36, but we picked the smallest one, right? So we picked the smallest one, so we're going to make both denominators 12, right? So I go back to my notes here. I'm going to this one here. All right, so we're doing this off to the side here. So if I'm going to make 3 into 12, I times this by 4, top and bottom. Shh. Alec, leave him alone.
Here's my shoe.
All right, and so that gives us 8 over 12, and I times this one by 3 to turn into 12. 3 over 12, right? So now that they're out of the same thing, we can say we have 8 12s, we have 3 12s, altogether we have 11 12s, since they're out of the same thing, right? So that's the way this works. We're adding these things together, we have 11 what? 11 12s. We gotta make the bottoms the same before we can count. Or subtract, add or subtract, right? Now, remember, if we multiply the top and the bottom by the same number, we did not change the value. Those are equivalent fractions. We just changed how it looks so we can execute some math. So 2/3 and 8 over 12 is the exact same number, right? So if I grabbed my calculator and I went 2 divided by 3, I get 0.666666, and I go 8 divided by 12, I get the same number, right? We did not change the value, we just changed how it looks so we can do some math. That's really important to understand, right? We're just manipulating the numbers so we can do calculations a little bit easier. All right, so let's do this. So we have 7 and a 3. We're counting sevenths, we're counting thirds. They're not a matched pair. We need to find a common denominator. So you grab your multiplication chart from the back. What would it be, Malik?
21.
21, right? So we go times this one by 3 to turn it into 21. Top and bottom. That's what keeps it the same number. Top and bottom. So if it's 15 over 21, and I'm going to move that negative sign to the top. All right? Then I'll have a plus sign. And I go, I'll turn the 7 into 21 after the 3 into 21 after times by 7, top and bottom, 14 over 21. Okay. So now we're counting 21s. All right, so that's what it's going to be out of.
-1 over 21.
Yeah, so you go, okay, negative 15 plus 14. What number is that? Ryan, you're right. It's -1. And you can use your calculator for that if you want. Negative 15 plus 14, -1. And that's it. All right? No extra tips and tricks from grade 8. That happens with the multiplication stuff. Just the way the fractions look, the numbers are going to be bigger. There'll be more negative signs, right? And the lead up to this is bed math, right? So you can do more complicated bed math stuff in grade 9 versus with grade 8. So, going over here. Lots of extra negatives. Now, when we cancel negatives off, it has to be on the same fraction. I can't take this negative over here and cancel it over there. We can't do that. We can only do that when we're multiplying and dividing because everything is connected. With adding and subtracting, the negatives have to be on the exact same fraction. So this negative has nothing to cancel with. So this negative stays on this fraction. So I have 3/4. I'm going to move the negative just to the top. So it shows it just with this, right? Now, we have a subtraction symbol, right? And now, the 5/6. We have two negative signs on there. So those can cancel each other out, right? So now, these two can cancel each other out. Cancel, cancel. And we end up with 5/6. No negative signs. Right? So that's what's making this chapter a little bit harder than last year. Okay? So we've cleaned up the extra negative signs. Right? Now we want to count. So we need to make sure we're counting the same things. We're out of 4, we're out of 6. We need to find a common denominator. So you grab your multiplication chart, or what's the common denominator for 4 and 6? What can they both fit into?
12.
12. Thank you. So they can both fit into 12, right? So you can use your chart if you want. To turn 4 into 12, we need to multiply by 3, top and bottom. So it doesn't change. So -3 times 3 is -9/12. Then we need to times 6 by 2 to turn that into 12. 10/12. And we have a minus sign between them. Okay? So now we do our counting. We have -9 minus 10. What number, Christian? -19, right? -19. Combine this one, this one, this one. Left to right. The bottom stays the same. Right? We have -19. Right? Now, this is an improper fraction. In my class, leave the answer as improper fraction. You don't need to turn it back to a mixed number. Unless I say turn it back to a mixed number. By default, just leave the answer the way it is. Okay? -19. All right. So, to make life more difficult, we have mixed numbers. Like I said, doesn't matter what chapter or what lesson we're working on, turn the mixed numbers into improper numbers. Right? How do we do that, Cameron? How do we turn this into an improper number? The bottom stays the same. What should the numerator be? Remember that?
Nope.
All right. Playing with your shoe. That's why I picked on you.
8.
All right. We ignore the 2. Ignore the negative sign. We multiply, then add.
8.
3 times 2 is 6, plus the 2 gives us 8. So we go 8 and throw the negative sign on the top. The 10 stays the same. All right. What should the numerator for this one be?
19.
19. 10 times 1 is 10, plus the 9 gives us 19. Right? And we have a plus sign. Okay. So now, before we can add, we need a common denominator.
30.
Not playing, man. Take notes. You haven't done anything.
30.
All right. Do you need to move your way here? Thank you. Malik, 30 would be it. Right? So, to turn this into 30, we times it by 10, top and bottom. Remember, if this is going really fast for you, oh, come on. You can look at the 3, you can look at the 10, look across, you'll find 30 in both of them. All right? You can do it that way. Go back. All right, so this becomes -80/30. All right. You multiply by 3 here to turn that to 30. We have 30. What's 19 times 3? Can you do that in your head?
57.
Riley?
57.
Yeah. All right, so
I have a handwritten chart.
57. All right.
I have to do that. 20.
Okay. Now we combine, right? We're counting 30s. So it equals 30ths. So we have negative 80 plus 57. Left to right. Negative 80 plus 57. What number did we get for there?
23.
Close.
Negative 23.
Negative 23.
Oh, so.
Negative 23. All right. Okay. Let's skip this one because I already did it with you guys. Off to the side. All right. Okay. Have you do this one by yourself? Right? What's your final answer? A little bit trickier on this one.
Can I say final answer?
No, give people a moment to do it. You can say it in a moment. So happy that most of you guys remember this from last year, right? Our common denominator is 10. I walked around, some of you guys used 20, which is fine.
Wow.
If you use 20, you're going to have to do an extra step of simplifying, right? So to turn this into 10, not both numbers need to change. We have 3 over 10 minus, move the negative sign to the top. We have 4 over 10. Now here's the thing. If you have two minus signs right next to each other like this, oops, they become a plus, right?
Yes, sir.
So the two minuses become plus. So we have 3 over 10. That becomes a plus. 4 over 10 equals 7 over 10. Now, some people walking around, they did it out of 20, and their answer was 14 over 20. If that was your answer, you're correct, but you have one more step. Because you didn't pick the smallest denominator, then you have to go divide by 2, you end up with the same answer. All right? Okay. Last question of the day. Oh, maybe no. I'm going to do one more after, on the back side here. All right. Let's combine extra negative signs first, right? So I said that you can't take a negative from the first fraction and cancel it with the second fraction. But you can take two negatives right next to each other. For instance, these two combined, they're right next to each other to make a plus sign, right? And if it's a positive number, we don't need to show that plus sign. So that just becomes cancel, 12 over 15. Now, these ones are right next to each other, and they can cancel each other out, right? And if they cancel each other, it's a positive number. But now we have two fractions without a sign separating. So we can get rid of the plus sign if it's out front. If it's between two fractions, we need to keep that plus sign. Because that positive sign then becomes an addition sign. It means the same thing, okay? Subtract a negative sign means add a positive number, right? Okay. So now, 15 and 6. Our denominators, they look different. So remember, we can't go cross canceling here. We can't take the 6 and the 12 and make it smaller like that, right? If you wanted, you can make the 12 and 15 smaller, right? But 15 and 6. We have a giant multiplication chart, which will hopefully load soon. There we go. All right. Sorry. Thank you, Ruben. Is it Ruben who said that? Max 30. Look across 15. We got 30 here. Look across 6. We got 30 there. So our common denominator is going to be 30. All right? All right, so go back to our notes. Yeah, they updated the app. It's not as stable as it used to be. All right, so we want to make it 30. So first fraction, what do we have to multiply by? Times 2. Top and bottom. So that's 24 over 30. Right? 30. Second fraction, what do we need to multiply by? 5 times 5 times 5. All right, that gives us 55 over 30 with a little plus sign. We add those numbers together, 79 over 30. So remember the denominator is staying the same here. We're not changing. It doesn't change 60 here. All right? All right. Now, can 79 over 30 be made smaller?
No.
Is there anything that can fit into 79 that can fit into 30? You can use the multiplication chart here to help you out. You look at it, and 79 doesn't have a sticker above it, so it's a prime number. Nothing can fit into 79, so that fraction can't be made smaller. All right? So that's as small as it can get. All right. Let's go on to the back side here. A couple of word problems. All right. All right.
Can I say the answer?
No. In a moment, you can help me out. Okay. So next question.
1.2.
Very important question. You can do a lot of these calculations next year. Right? It says one day in January, Prince George, the temperature was negative 10.6 degrees Celsius at 9 o'clock in the morning. Then at 4 o'clock, it went up to 4 p.m. And the question is, well, the final question is, what is the average rate of change? I'm going to break it down into steps for you guys. Okay, so now you're going to see that word a lot next year. Rate of change. So when you do science class next year, you're always measuring change. How quickly did the temperature drop? Right? How much product did you make? Right? That's how much. That's your change, and your word rate is how quickly did it happen. Right? So rate of change calculations are always done the exact same way. Right? You have your change divided by the amount of time it took for that change to happen. That is your rate. Always. And you're just measuring different things. You might be measuring pH, right? How does the pH change when you do it? Or you might be measuring concentrations or something like that. But it's like, how much did the change happen? And how long did the change take to happen? And that's your rate. How quickly is this reaction taking place? Right? So here, change. How do you calculate change? That's part A. The formula for change is always exactly the same. Is your final measurement minus your initial measurement. That's the difference. The difference between where you started and where you started. That's your change. Final minus initial. The difference between where you started and where you ended up. All right? Should be another I there. The I didn't show up nicely. Initial. Right? It's a difference calculation, always, whatever you're measuring. Right? All right. So on this question, what was our final temperature? Riley?
2.4.
2.4. So we got 2.4 as our final measurement. What's our initial temperature?
Negative 10.6.
Negative 10.6. And we subtract these two numbers. All right? That's our change. All right? So you go, okay, what's our change? These two minus signs now make a plus.
13.
So you have 2.4 plus 10.6, which is a 13-degree change. All right? Now, you're going to have to be careful with change. It's going to be either positive or negative. And it makes a difference, right? If it's plus 13, it means it went up 13 degrees. If it's minus 13, it went down. Right? So the amplitude of the sign makes a big difference. So you're going to have to be careful. So that's telling us the temperature rose. It didn't drop. All right, now how quickly did the change happen? What was the rate? So the rate calculation is always the same. Rate is change divided by the time it took for the change to happen. So that's 13 degrees over the time. So how long did it take for this to happen?
2.
Right? It started at 9 o'clock in the morning at the first temperature. The last temperature was at 4 p.m. How much time passed by? 7 hours. Between 9 and 4 is 7 hours. Okay, so then you grab our calculator. Here we go. With rate of change, we don't leave our answers as fractions. It's always a decimal calculation. So we go 13 divided by 7. 13 divided by 7, we get 1.85. So let's just write down 1.86. Okay. Now that's just a number. 1.86 what? We need some units attached to this. Sorry? That's a part of it, right? So how do we figure out the unit? Well, on the top, we're measured change, right? We divided by how much time it took place. That's measured in hours, or HR.
So per hour.
So it's degrees Celsius per hour. Top unit divided by bottom unit. The slash line means per, also means divide. So it's your first unit over your second unit. So it changed 1.86 degrees per Celsius per hour. So now once you have that number, you can say, how much is the temperature going to rise by in 2 hours? Well, we just doubled that. 3 hours, we tripled that. All right? You can figure that out. So you get a little sentence, right, with the word problems. The rate of change for the temperature is 1.86 degrees Celsius per hour.
What average? But they were average. What about
Per hour, yeah.
it said average rate of change.
Oh, that is average, right? Yeah. All right. Okay. Final question, then we'll stop for the day. All right. A budget question, right? So we have the Rodriguez family. They make $6,000 a month. That's how much they take home. And then this says, this is how they budget their food, their income. A third of it goes to rent. A third of it goes to food. A quarter of it goes to rent. A fifth of it goes to clothing. And then they save 10%. Oh, sorry, 1/10 for savings. And then he goes, hey, after they shelled out all the money for all the different kinds of expenses and savings, how much money do they have left over at the end of the month? Right? So they go, they don't give you how much money they spend on food or on rent. We need to figure that out. Right? We talked about this last day. If I say a third of their budget went to food, what does the word of translate into? Times. So third of what? A third of 6,000. So for food, so we need to figure out how much money did they spend. So food, a third of, so third times 6,000, right? So that would be just 6,000 over 3, right? Can you do that in your head? How much money is on food? Thank you, 2,000. They spent $2,000 on food. Then we go on to rent. And they say they spent a quarter of their budget, quarter of 6,000. So that's 6,000 over 4. Can you do that one in your head? Malik?
1,500.
Sorry?
1,500.
1,500. And you can use your calculator. You go 6,000 divided by 4, right? That's all that is, right? 6,000 divided by 4. Oops, I need another 0. 6,000 divided by 4. 1,500. Right? 1,500. Then we have A third of our budget goes to food. No, sorry, a third, not food. Clothing. A fifth. A fifth for clothing. Clothing. 1/5 times 6,000. So that's 6,000 over 5. Can you do that one in your head?
1,200.
Thank you. 1,200. All right. And finally, we have savings, which is a tenth,
600?
which would be 600. So 6,000 divided by 10 would be $600. Right? So these are all their expenses and savings. They all combine up to how much money? Sorry?
300.
5,000. Yeah, so 5,300. Let's just double check. So we go calculator. We get 2,000 plus 1,500 plus 1,200 plus 600, $5,300. So how much money do they have left over at the end of the month? 700, right? If they have 6,000, we go. Amount left over is 6,000 minus 5,300, which is $700. Right? So that's it. So we'll stop there. We got about